What's up? Coach Hyde coming at you with the vlog for the Hyde Science website. Um, excuse me. Working on the solubility curve. We're in Unit 4. I want to kind of hit a couple of the biggest topics you'll see on your left side of your screen here. So these, what I just highlighted, that is going to be our topics for today. We're going to run through those. These are the big things we got to get under control as we're moving forward. Make sure we understand. Make sure we're ready to rock and roll with it. All right. So first off, I'm learning, right? So what are the solutes, right? This is our first thing. So the solute is dissolved into the solvent. This makes the solution, right? The solute is dissolved into the solvent. Together, this makes the solution. So we're going to go ahead and answer both of these questions together, okay? So if you look over here on the graph, right, NaNO3 is a solute. It is dissolved into the solvent, which is water. CaCl2 is a solute. It is dissolved into the solvent, which is water. Lead nitrate, yep, that's a solute too. It's dissolved into the solvent, water. So if you see, all of these are solutes, and then water here is our solvent. Now, we're not obviously dissolving all of these things into water at one time together. This is just one graph that represents all of these separately, right? But it's just it's easier to look at one graph than look at 27 graphs of solubility. So we're not putting them all in together. They're completely separate. Focus on one solute at a time, but it's all there on one graph for convenience. All right, next up, looking at these. All right, what's going on? Is it working? Okay. How do I know how the temperature affects the solubility? So one of three things could happen: either increase solubility, decrease solubility, or it doesn't really change anything. It's all based on temperature change. So if we look down here, here's our temperature right here, right? So the temperature gets bigger from 0 to 100. So our temperature is changing that way. So we need to look, how does it affect these lines? How does it affect these solubility curves when it changes? So we're either going to kind of get one of three things. We're going to get a line that goes up, we'll get a line that trends downward, or we'll get a line that doesn't really change much. Right? So most of these lines are moving up in some way or another. So most of these things, the amount of solute, remember these things over here, the amount of solute is going to get bigger as the temperature increases. But for some of them, this one, see how it goes down? It kind of levels out. So this one, as it heats up from 0 on, these numbers, the solute gets smaller. So it's going to decrease solubility as we increase the temperature. Right, and then now we're looking at the last case scenario where the temperature does not really affect. Look at NaCl. NaCl is going to start off here about what, 34 grams solute at 0 degrees Celsius. If we heat it all the way up to 100, right, to right there, now it's only at 40. So we increased the temperature 100 degrees, and we only gained 6 grams of solubility. So the temperature didn't really made a difference. It didn't really do much, right? It ain't worth going home talking and bragging about. Right. All right. So that knocks that one out. Now we're going to go on to the next one. How to use the solubility curve to determine if the solution is saturated, unsaturated, or supersaturated. So again, looking over here at this window, we're going to have to plot coordinates, and it'll be prompted. It'll give you, a coordinate, and it will tell you to focus on one specific. So let's focus on KCl, right? If the temperature is 40 degrees, we had a solution of 50 grams. We would plot this point right there, right? If we're focusing on this KCl line, right, focus on this line, this point ends up above the line. If it's above the line, it's supersaturated. Right? Let's say we didn't put 50 grams in it. Let's say we put 30 grams in it, right? 30. So 40 degrees, 30 grams. We plot this point. All right, now it's below the potassium chloride line. So now it is unsaturated. It has to hit dead on that line. So in order to have a saturated solution at 40 degrees, we would need roughly 39 grams. That's slightly below this. We'll say we would need 39 grams of solute. This would hit directly on this line, right? This is the only way we can get a saturated solution. All right, we got to make sure you focus only on the line you're dealing with. All right, so let's say here, this spot, this coordinate's at 40, 39. This would be a saturated solution for KCl. But what if the question asked you about KNO3? Although it will be a saturated solution for KCl, this point now is below the KNO3 line, so it will be unsaturated. So make sure you focus on which line you're dealing with. All right, got that knocked out. Moving on. So, lastly here, how to solve or how to determine solute quantity, can't read my own typing over there, with a solvent that doesn't match the graph. For example, how much potassium nitrate, KNO3, so we're talking about this one over here, will form a saturated solution at 200 grams of water. Now, this is where our problem comes in. This is where a lot of people struggle with. It says 200 grams of water. We only have 100 grams of water, right? So this graph can't tell us that. What this graph can tell us is at 20 degrees Celsius, for this graph, we can put in, what we're talking about, KNO3, we can put in, right there, right, 30 grams. See that? So we go up to 20 degrees Celsius till we hit our line. We look over and we say, okay, well, this is what this graph tells us right here, right? So, I'm going to rewrite that in purple. This tells us we can put 30 grams of solute into 100. Now, the question asks us how much can we put into 200. So we got a proportion set up here. The ratio is the same. 330 divided by 100 is going to be the same thing as whatever this is divided by 200. All right, just saying, it don't matter how much solvent we have, ratio is always going to be the same. And I can work this out mathematically, cross multiply and all that good stuff. But hopefully you can just notice that, hey, 100 is half of 200. Right? So I had to double it to get there. So whatever goes here, I'm going to need to double it, right? So my answer is going to be 60 grams. It would be 60 grams and 200, right? It'd be what? 90 grams and 300, 120 grams and 400, 15 grams and 50, right? It's all a ratio. It's all based off of whatever this ratio gives us here. All right, so that's the down and dirty. That's all of them, right? That's the most basic fundamentals of this graph, I believe so. It should kind of help you get through these, get through the questions. Let me know if there's something you come across, and I'll get a video on it.